Alright, so today we're going to talk about least common denominators, as we discussed just now. When do we need least common denominators? When you are adding or subtracting fractions. That's correct. Very good. But before we get there, let's do a very simple problem that looks something like this. It says complete. Fill in the blank. Okay. You got 3/8 equal to something over 40. You should all know how to do this without any problem. Okay, we could always change the denominator of a fraction. Okay, this is something else. Actually, you can change it to anything you want, really, except 0, I guess. Oh, okay. So what should I do here? What kind of work do I need to show? Anais.
You need to times 3 by 5.
I need to multiply the 3 by 5
And the 8 by 5.
and the 8 by 5. You're right. You don't just multiply one, right?
Yeah.
Just the numerator. You have to multiply top and bottom, the numerator, the denominator. Because after all, what does 3/8 equals? What's the value of 3/8? Is that equal to 15 over 40? Yeah, they're the same. Why? Aren't we multiplying this fraction by some number? Why does the value stay the same? Here.
Oh.
Raise your hand. Okay, cool. Kobe?
Oh, it's because you're multiplying it by 5 or 5, 5 or 5.
Yeah, you're basically multiplying it by 1, right? So even though the fraction looks different, their values is exactly the same, right? 3/8 is the same as 15 over 40. Right, guys? So sometimes you want to have different denominators because, like I said before, when do we want to have different denominators? When you are adding or subtracting fractions, right? So let's say you had 3/8 and then another fraction was something over 40, right? You want to make 3/8 into, right? Something over 40. Okay, so same thing there. Okay, what about this? What if I have variables? Does that make much difference? No, it's the same idea. So I got 7 over 4y equals to something over 12y cubed, and they have to be equal to each other. So what do I need on the numerator? Okay, so what do I do here? What kind of work? So the one before we multiply over 5 over 5. Okay, go ahead.
You have to multiply by 3y squared.
3y squared over
3y
3y squared. Very good. Where did she get the 3y squared from? That's right. Yeah.
To get 12y cubed, you have to multiply 4y times 3y squared.
Exactly. You're looking at 4y and you go, okay, what do I need to multiply 4y so that it becomes 12y cubed, right? And you guys are all correct. Okay, so you get 12y squared over, 21y squared over 12y cubed. Again, I wrote down that 3y squared over 3y squared is 1, right? It doesn't, right, change that much. Whenever you have variables in the denominator, by the way, it does actually change a little bit than just numbers. We'll explain that later. Anyway, let's go to example 3. Are we okay with this? Easy? Okay. So now we want to find the LCD here. Okay, find the LCD. Move it up. So to find LCD, we haven't really found any LCD on the other ones before. But to find LCD, there are really 2 steps, actually 3. Depends on how you look at it. Okay, so first, whenever you want to find an LCD, okay, if you have fractions, anybody want to guess or already know what the first step is? Whenever you have a bunch of fractions, you want to find LCD, you better do this first. It's going to help you a lot when you do this. Yes? That's right. You factor. Factor each denominators completely. Another name for that is called prime factorization, or you just do factor tree, right? So step 1 is kind of like GCF. Remember when we were doing GCF, isn't this what we did too? But step 2 is completely different than GCF. So step 1, you factor each denominator completely. That's what you do. You do a factor tree. We all know how to do that, right? So. And step 2, let me tell you what I wrote down. This is my own words, if it makes any sense. Okay. All right. So. Oh, go back. Sorry.
Go back.
I am. Here. You good? Aaron, you good? It says just write factor each denominator completely. That's and another name for that is okay. Step 2 is this: write all the factors that were used in the factors of the denominators without any duplicates as products. And Then there are two steps. There are two parts in step 2. Then you choose the highest exponents from each factors. So it sounds like a lot of work. It's not really. When you see me do it, you go, oh, that's pretty easy. So write this down. Write all the factors that were used in the factors of the denominators without any duplicates as a product. Right, as a product. Choose the highest exponents from each factor is the second part. Maybe I should write the product of all the factors. Wouldn't that be, because product is important, right? That's okay, you don't have to change this. Write the product of. Write the product of all the factors that were used in the factors of the denominators without any duplicates. Okay, and then you choose the highest. By the way, actually doing or finding the LCD, these steps are really easy. What's important though is you understand why we do these steps. Okay, don't just blindly follow these steps without really understanding why we're doing it. Okay, because that's not going to help you remember for a long time. You know what I mean? You have to understand why do we write why do we write the product of all the factors, and why do we choose the highest exponents? Okay, why do we do this? Okay, so that's the important part. So, anybody need more time to write? May I go into example then? Let me show you how to do this. Okay, how many people completely understand step 2? Let me show you. It's easier when I show it to you. Okay, so let's see if this makes sense. There you go. So now if I have this, yeah, question? Yeah.
If we're finding the lowest common denominator, then why do we find the highest?
Yeah, see, isn't that kind of weird? Aren't we looking for the least common denominator? Why do we choose the highest exponent? Yeah, that's why I even highlighted this one. That's a very good question. Kobe, and I think I'm glad you're asking that question, because think about that as we do this, because otherwise, if you just blindly follow these steps without really thinking about it, then you're going to choose the wrong exponent and get it wrong. Okay, so that's very good. Okay, so example 3. Let's do this example 3. Look at these fractions. I like this fraction. Why? This fraction looks kind of interesting. You don't get these kind of fractions a lot, do you? Why is this one nice? Shrug?
Because it's all it's already factored.
Yeah, it's already factored. I did the most important, the hardest problem of this type of question is factoring out the denominator, and I did it for you. So I did that just to make it easy. Do you think you're gonna see these things like this on your homework or test?
Sure.
No, you're not going to. Okay, but for this example, I just gave you an easy one. So I did the factoring for you. Now all you have to do is step 2. So it says, what does the step 2 say? It says write the product of all the factors that were used in the factors of the denominators without any duplicates. So, what do I mean by that? By the way, it basically means write down all the factors that were used in both of these fractions, of the denominators of the fractions. Which factors were used on both of these denominators? Judy? 3 and 7 were only factors that were used? What about 3 and 7? Oh, 3 and 7 are the common ones. You're thinking about GCF. You're right. When we were doing GCF, we looked at the common factors. This time, we're not looking at the common factor. We're looking at all the factors that were used on both of the denominators. So, tell me all the factors that were used. Yeah, tell me. 2. Yeah, 2 is 1. 2, 3. By the way, should I write 3 twice? No, that's what I mean by don't write it twice. Duplicate, no duplicates, right? 2, 3. What else? 7, 11, 17. Aren't these the factors that were used? Right? By the way, these are factors. So I want the product. So make sure you put dots. Make sure it's multiplication. Otherwise, it looks like a really big number, right? Looks like 2, 3, 7. Anyway. And then we're not done. Yeah, question?
Didn't you say choose the highest exponent?
Yeah, I'm not done. You're right. So we gotta choose the highest exponent. Very good. So step 2, the second part. Okay. Why don't you tell me? What do I do? 2 to the what power?
Oh, 2 to the third.
Yeah, 2 to the third. Well, there's nothing to choose from. There's only one factor of 2, right? What about 3 though? Oh, 3 has 3 to the 5th, 3 to the 5th. This one, right? Nothing to think about. 3 to the what now? Which power? 3 to the 5th. What about 7? Oh, we have now decisions to make. Do we choose 7 to the 5th or 7 to the 2nd power? 5th, I said we choose the highest. And Kobe was wondering why, you know. Anyway, so let's think about that. What about 11? 11 to the third, 17 to the first. Okay, that's your LCD. You're done, guys. Easy. Okay. Well, like I said, doing these steps are easy, but do you understand why? Why do we? Just Kobe asked a really good question. So right here, if I chose 7 to the 2nd power instead of 7 to the 5th, right? Wouldn't that give you a smaller denominator? Isn't that better? Not quite. Does anybody know why we can't choose 7 to the 2nd? Why do we have to choose the higher exponents instead of lower? Oh, 1, 2, 3. Anybody else? 4 people? Come on. Think about it. Why can we not choose 7 to the 2nd? Why do we have to choose the highest exponent? Emily, what do you think?
The denominator and the higher the denominator, the less the
Oh, not quite. You're right in that if the denominator gets bigger and bigger, yeah, the fraction is smaller and smaller, right? But I'm talking about in terms of the numbers here. We were looking for least common denominator, right? We're looking for smallest denominator. So if I would have chosen 7 to the 2nd, yeah, the denominator would get smaller, right? But how come we can't do that? Oh, Elizabeth? That will be the GCF. Yeah, that will be kind of doing the GCF. You're right. That will be the common factor. But still, you're kind of close. Yeah, Marilyn?
Because if you did, because we have to do 7 to the 5th because that's the highest you can go, so that when it's a fraction,
Pretty good. Pretty good. Yeah. Anybody want to add something to that? You got it. You almost. I think you understand it. Is there anybody want to else add to that? Yeah.
Because if you pick the lowest one, then it'll only cover 1 as a fraction.
Yeah. If you choose 7 to the 2nd power, right? That's what you're saying, right, man? Yeah. This fraction is fine, but what about this? There's no way this one will go into this common denominator, right? It would not be common denominator anymore, right? There's no way 7 to the 5th will go into 7 to the 2nd. Is that right? You know what I mean? So we have to make sure it's big enough. We don't want to be too big. I mean, I could write 7 to the 50 if I wanted to, but that's too big. We want the smallest, right? What's the smallest number we could use? Well, it's got to be 7 to the 5th, right? Does that make sense? Well, that's factor of 7. It has to be big enough. Now, that kind of answers this question too. Why do we have to choose all factors, right? You know, like for GCF, we chose the common factors only. Here, we wrote down all factors. Why do we need all of them? Because the same idea, if we were to leave out like one of them, like for example, if I left out 17, right? Well, this fraction is fine, but then the other one, is there any chance this fraction will go into the LCD? No, there's no way. You gotta make it big enough, right? Right? So that's why we list all the factors, okay? Does that make sense? So that's why we choose the highest exponent. We good? Are we good? Do you get the idea? Okay, may I go into example 2? All right, let's go to example 2. Again, I have example 4. I'm so nice. I've already factored out the denominators for you. All you have to do is find the LCD. Everybody go ahead and try. I'll give you some time. All right, so like I said, this one's nice because step 1 is done for you. It's already been factored. Step 2 says list all the write all the product. What did I say? Write the product of all the factors that were used, okay, without any duplicates. So Matthew, tell me what to write. What are all the factors that are being used for both of these fractions? 2, 3, 5, 7. Yeah, don't forget 7. Okay, then x, y, z. Okay, by the way, it looks like 2,357. That's not good, right? So I should put down some here, like make sure it's product, right? I'm not done. I have to now choose the highest or lowest? Highest. Remember, it's got to be big enough. Otherwise, okay, Andrew, tell me what to write. 2 to the what? Third. 3 to the? Fifth. 5 to the?
Second.
Good.
7 to the first.
Yeah, that one just, okay. X to the?
Third.
Good.
Fifth.
Y to the?
Fifth.
Good.
Z to the seventh.
You got it. Okay, there it is, guys. How many forgot this? Raise your hand. Easy? If you didn't, if you didn't, ask me. Yeah, question? You got what? Oh, you did? Okay. That's good if you did. If it's big enough like this, you don't have to. But yeah, what'd you get, by the way?